The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Sorry for the delay in getting started. We will be starting the webinar in just 1 or 2 minutes. Okay, sorry about that. Hello again, everyone. Thank you for joining this webinar. I think I know most of those who are on this who have joined today, but for anyone who doesn't know, my name is Kishore Ramaswamy. I am an application engineer working in the Troy, Michigan office. The purpose of the webinar today is to explain our new platform for SOLIDWORKS customers. So that would be the SPEOS for SOLIDWORKS platform. I don't expect it to take the full hour today, probably closer to about half an hour. If there's any questions, I can take them at the end of the session today. So just a quick introduction. As probably some of you have heard or are maybe already aware, with the 2017 release of our softwares, for SOLIDWORKS customers, we have brought a new platform called SPEOS for SOLIDWORKS. And the idea of this platform is to bring the power of the SPEOS kernel. So this is something that was used in our other platforms, so the CATIA and NX versions, to bring this kernel into SOLIDWORKS and gain all of the capabilities that existed within some of the other platforms that we had. So this has now arrived in this 2017 version with both the add-in and studio versions for SPEOS for SOLIDWORKS. So OPTISWORKS add-in will translate to SPEOS for SOLIDWORKS add-in, and OPTISWORKS Studio would translate to SPEOS for SOLIDWORKS Studio. There are several features that are enabled by this transition, which I will show throughout these slides. There are some aspects that were not imported into this new version, and I will describe some of those as well. So the main difference from my perspective between SPEOS for SOLIDWORKS and OPTISWORKS is the way that we handle material properties. So in OPTISWORKS, we were using a surface-based modeling approach. And in this approach, all surfaces would be given a surface quality, a internal material, and a external material. In SPEOS for SOLIDWORKS, we've transitioned into a solid-based modeling approach. So in this case, instead of optical properties being applied to surfaces, they are now applied to solid bodies. So we have volume optical properties and surface optical properties instead of surface quality, internal material, and external material. By doing this, there are several advantages that we can leverage and several benefits for modeling. So the first is that tangent bodies are now handled automatically by the software. So this has always been, in the OPTISWORKS platform, something that has been a bit difficult to handle. Whenever two bodies were in contact with each other, there was quite an elaborate process that needed to be taken into account using this transparent surface quality. But now using this solid-based approach, this tangency between solids is handled automatically by the software, and it makes it considerably easier for modeling these types of products where you have bodies that are tangent to each other. The other thing that it allows is that a single part can now have multiple bodies that have different optical properties. So previously in OPTISWORKS, every part had one set of optical properties, and if you had several bodies within that part, they would all be given the same optical properties. So the traditional approach was to create a separate part for each body. With the new version, you can have a single part containing several bodies, and each body will be given its own set of volume optical properties and surface optical properties. The interface is more or less kept the same. The main differences are things like you see here on the screen, where the names of the properties have changed from this internal material and external material into volume optical properties and surface optical properties. So just to provide a quick example of previously what would occur and now what happens. So looking at the top image, this was taken from OPTISWORKS. When there's a small air gap between the two bodies, you can see the rays are transmitting through the light guide all the way to the end without any issues. But as soon as this air gap is removed, so as soon as the two bodies were tangent to each other, several errors were introduced into the simulation, as indicated by all of the X's that you see in the right image. So typically, this is the process on the left is actually what was done, where bodies that were in reality tangent to each other were actually modeled with a small air gap between them. With the new software, or the new platform, I should say, going from the image on the left to the image on the right does not require any additional steps, and you can see that the ray trace actually functions correctly with the rays propagating all the way through the light guide without any additional steps that need to be done. So this is a considerable improvement and should make modeling tangent surfaces and tangent bodies considerably easier. Another element that was introduced, and again this is due to the new modeling of solid bodies instead of surfaces is a feature called simulation suppressed bodies. So this is a way of essentially removing a body from a simulation without having to actually suppress the entire body inside of SOLIDWORKS. So we are essentially virtually suppressing the body by not including it in our mesh. So on the left, in this case, there are no suppressed bodies, and the ray trace functions as we saw on the previous slide, with the rays going through the first body and through the second body. On the right, we have selected the second body of this light guide, so the second part, to be a suppressed light guide body. So we can still see the light guide body in the model, but the simulation will consider it to be a suppressed body. And in this case, the mesh does not show on the right side. So this means that the simulation is not taking into account that body. And in the ray trace on the bottom, you can see the same effect. So the second body has not been meshed, and the rays are essentially ignoring this second body. So this simulation suppressed bodies is a way that we can tell the simulation to not take into account different bodies in the simulation. Another feature that has been introduced into the SOLIDWORKS platform is what we call a simulation export. So this is something that has been possible in our other platforms and now is possible inside of SOLIDWORKS. Doing an export of a simulation allows for two important capabilities. The first is that the simulation can be run in what we call SPEOS core. So this is the calculation engine that the software is using, except instead of running the simulation inside of SOLIDWORKS, we run it outside of SOLIDWORKS. And so what this does is that the simulation is allowed to continue running without actually locking up your SOLIDWORKS and without preventing. So traditionally, when the simulation is running, you wouldn't be able to continue working inside of SOLIDWORKS. It would run inside the SOLIDWORKS platform. Using this simulation export, you can run the simulation in the background and continue working inside of SOLIDWORKS. The second thing that the simulation export will allow is what we call HPC, so high performance computing. Essentially, taking this exported simulation, we can now distribute it to several workstations or several servers and have these servers all compute the simulation together, which does two things. One is that it frees up your own computer from simulating, and the second is that it significantly increases the speed of a simulation. So you can get results for complex systems very quickly. So you can imagine a situation where all of the workstations in your office could be technically connected together, and overnight they could all be used to run OPTIS simulations so that the results can be available at a much faster rate, and it can also go through a queue of several simulations to have them all ready the following morning. The benefit here, because we're using HPC, so this is a Windows process, on all these other computers, no OPTIS software needs to be installed. We are simply leveraging their computing power to run our simulations. Some additional benefits that I think are worth noting. There is a long list of differences that I will go through. I'll go through some of them, but there is another document that that contains all of the changes that have taken place. But these are benefits that I think are worth noting. So the first is something that I've mentioned already. Solid bodies within an individual part do not have to have the same optical properties. So we can apply specific properties to every body within a part. The second is that direct simulations Instead of the typical option of setting the number of rays the simulation will run, we can instead choose a duration. So this will set how long the simulation will run for in cases where we don't necessarily know how many rays we want to run, but we know exactly how much time we have to run. So you could set the simulation to 3 hours and it will run as many rays as possible within 3 hours. Some additional features which may or may not be applicable to the particular use case that you have, but the fast transmission gathering, which previously was called fast transmission caustics, can now be applied on individual bodies instead of being a global simulation setting. So you can select the specific geometry that you want to apply the fast transmission gathering property instead of setting it for the entire simulation. The inverse simulation now uses a number of passes instead of calculating the value from a precision input that we used to use on the sensors. So previously this number of passes was computed from this precision value. Now it's something that we set directly. And lastly, the splitting and dispersion parameters for inverse simulations can now be deactivated if required. And what this allows us to do is to increase the speed of inverse simulations by deactivating these parameters in cases where they were not required. So the next thing that I'll do is go through the main or the differences from OPTISWORKS and SPEOS for SOLIDWORKS. A lot of these slides detail some minor changes, so specifically just the location that some parameters used to exist and where they are located now. I will try to go through this quickly as it's probably something better to have on hand and to refer to it as required, but it's still good to see overall some of the changes that have occurred. So first of all, some parameters that used to be located as in simulation parameters, so these were settings per assembly, per project, have now been moved into what we call system settings. So these are global settings for the entire software instead of assembly-specific settings. So these include the increment name setting, the number of threads, and the warnings for simulations. So these are all now system-level settings that can be set and applied to every assembly and every project that you're working on. Also, the default optical properties, since we're changing to this solid-based modeling, the surface quality, internal material, and external material have been converted into volume optical property and surface optical property. Some minor changes for surface sources. Instead of using the half angle, it now uses the full angle. So a Lambertian 90 degree will now correspond to a Lambertian 180 degrees. Also, if you're using variable excidence, so this was used typically when the emission surface of a source was not constant, when more light was located within a specific area. Previously, the orientation was done by the surface itself. Now we choose an origin and an X and Y direction to orient this emittance. I won't go through this whole list. These are just, again, some minor changes that have occurred at the sensor level. So one nice addition is the colorimetric option for sensors. Previously, there was only a spectral option when color was desired. The colorimetric option will still provide the color coordinates without having to store all of the wavelength information. So this reduces the size of these files and also the time that was required to actually create the file itself. lot of the simulation parameters have been moved from the general simulation parameters section and moved into the individual simulation section. So, for example, here what's shown is the interactive simulation. In that interactive simulation parameters list, it now incorporates a lot of the settings that used to exist inside the simulation parameters. So we can actually set the interactive simulation and the direct simulation and the inverse simulation to have different simulation parameters instead of having the general simulation parameters control all three of them. The important thing to note here, or to keep in mind here, is that if a setting you're looking for is not where it used to be, this is a good document to refer to find out where the setting has moved to. So the ray tracing drop-down inside of the ribbon has been removed, and the interactive simulation is now joined with the rest of the simulations. So these are all contained within the simulations drop-down. Same thing for direct simulation. The settings are now contained within the direct simulation parameters. And you can see there's a checkbox now for duration. So you can actually set a number of rays and a duration, and whichever one is reached first will terminate the simulation. Inverse simulation, same thing as previously mentioned for the direct and interactive simulations. So 3D textures is something that has also changed slightly. Nothing that would really limit the use of the module, but the two aspects that have changed. Previously, for patterns, we were inputting a text file, and so we had to take the SOLIDWORKS part, export this as a text file, and then use the text file inside of this pattern definition. So in SPEOS for SOLIDWORKS, we can now input directly the SOLIDWORKS part file instead of having to export it as a text file. The second is that instead of applying the texture on a surface, it will use the entire body as a selection, and then the actual surface that will be applied is determined based on the origin point and the shift setting. So it's just something to keep in mind, not something that will necessarily change how it's used, but we are now selecting the entire solid body instead of an individual surface. And lastly, the add layer option in the Boolean operation dropdown has been removed, and instead we have add on same material and add on different material, depending on if the pattern has the same material properties as the body that it is being applied to. So an extra note that the optical design, so the OPTIS module, this has been removed from the SPEOS for SOLIDWORKS platform. And on that same note, this is essentially a list of the features that were not imported into SPEOS for SOLIDWORKS. Some of them I have mentioned already, but the full list is contained here. The first two I think are not necessarily that they were not imported, but they've been changed to volume and surface properties. So the main features that were not imported into SPEOS for SOLIDWORKS are the volume source, the thermic source, the OLED source, the optical lens, and the straight light analysis. And for 3D textures, it has essentially been imported except for this add-on different layer is the only feature that was not imported. And then a final note for automation. So if you were previously using a script or a macro inside of OPTISWORKS, some of the objects and methods might have changed inside of SPEOS for SOLIDWORKS. So the names of some of the methods or the objects that were being called inside of a macro may be slightly different in the new version. In terms of licensing for this new platform, the SPEOS for SOLIDWORKS platform, essentially for any customer that is under maintenance still, there is no cost to obtain a license for SPEOS for SOLIDWORKS. So this is given for free to any customers that are under maintenance. You can have both OPTISWORKS add-in and SPEOS for SOLIDWORKS add-in licenses at the same time, and you can have both softwares installed at the same time. They will show up inside of your SOLIDWORKS software as two separate add-ins, and you can switch between the two as required. For the Studio version, because the Studio installs SOLIDWORKS at the same time, you can still have a license for both OPTISWORKS and SPEOS for SOLIDWORKS. However, only one can be installed at any given time. So you can only have either OPTISWORKS Studio or SPEOS for SOLIDWORKS Studio installed. There are some workarounds in this case where you would need to have both installed. So I would suggest to simply contact me if you are in this situation, and we can sort of go through what needs to be done for your specific case. An important note is that while you can have both installed and use both concurrently, all future development for the future versions will all occur on the SPEOS for SOLIDWORKS platform. So the OPTISWORKS platform will still be supported, but all development will now take place on the SPEOS for SOLIDWORKS platform. And lastly, just to note that to obtain a SPEOS for SOLIDWORKS license, you should send an email to naSupport@optisworld.com and simply request the license. We will put in the necessary request to our license team, and it should be generated within a day. You should have your new license. Some recommendations for this new platform. What we recommend is that customers continue using OPTISWORKS for existing projects and start using SPEOS for SOLIDWORKS for new projects. So any new models that you're building, we would recommend that you switch over to the new SPEOS for SOLIDWORKS platform. But for old models that you are currently working on, to stay within the OPTISWORKS platform. The main reason for this is that while there are some features in common between the two, which will be visible, there are some features that are not compatible within SPEOS for SOLIDWORKS and OPTISWORKS, and these will not be preserved during a migration. So if you open a OPTISWORKS project inside of SPEOS for SOLIDWORKS, you will firstly get the following message. So it will warn you that some properties and some attributes and some features were generated inside of OPTISWORKS and will either be ignored or were not successfully migrated. And essentially what you will have to do is go through your model and fix all of the migration issues. So things like optical properties will have to be reapplied to all the different parts because now we're doing volume properties instead of surface properties. And also some of the settings that you were using in OPTISWORKS, because the location and in some cases the actual setting itself, because they have changed, some of the settings that were not in common will be reset to their initial default value, and you may have to go through your project and check all of the simulation settings and meshing settings to ensure that nothing that was necessary has changed. It is possible to do. I have done this with several projects that I was working on in OPTISWORKS, but it does take some time, and it will be up to you to decide whether you want to go through this migration process or simply begin new projects in SPEOS for SOLIDWORKS. There are some features that are quite nice, and so it might be worthwhile to go through the migration process to leverage some of these new features, but that will be a personal decision. And the last note is that OSD features, so anything created with the optical shape design module that were created inside of OPTISWORKS cannot be modified in SPEOS for SOLIDWORKS. So the feature itself will still be present, but you won't be able to make any modifications to this feature if it's opened within SPEOS for SOLIDWORKS. And lastly, for the full list of changes between these two platforms, this is listed inside the documentation, but also if you would like to have either a copy of this presentation or another document which we have which explains all the differences between the two, send me an email or contact support and we can provide you with this documentation. So that's all I have for today. The main goal here was to explain the new platform and some of the changes that will be taking place. If there are any questions, I would be happy to answer them either now or offline. I will try to see if I can find the questions. Okay, if anyone has any questions, I've turned off the screen sharing just to hide the screen, but if anyone does have any questions, please feel free to use the question feature in the GoToWebinar, and I can answer those for you. George, I think you have a question. But let me see. George, if you have a question, you can type into the question dialog, and I can answer that. So Vladimir had a question about whether the new platform will support the Fornell beacon lens. So Vladimir, to answer your question, currently the optical shape design is the same as it was in the OPTISWORKS platform, but the beacon Fornell lens is being worked on, and we are hoping that it will be available in the next release of SPEOS for SOLIDWORKS. Harold, to answer your question, whether a node lock license can do an export simulation, yes, it can. So even if you have a node lock license, you can export your simulation. You won't be able to run on several servers or several computers without an option added to the license. So this would require this HPC option, but you can still run the simulation locally on your computer inside of SPEOS Core, even with a node locked or any existing license. Marie, to answer your question, the global rules will remain identical. So everything that was in OPTISWORKS will still be there inside of SPEOS for SOLIDWORKS. George, I'm not sure if I understand your question. Can you elaborate on that question? Marie is asking if HPC is an additional cost. So yes, to leverage the HPC simulation, so to be able to simulate on additional workstations or additional servers, there is a cost. The nice part about it, let's say, is that the HPC license is shared among all existing licenses. So if you have 4 SPEOS licenses, they all share the same HPC license, so all 4 of them will be able to distribute to multiple computers at the same time. But it is an option that has to be purchased for your license. Harold's asking about the tangent bodies management. So it is similar to the way it works in our CATIA version, and actually in the other versions as well. The main difference for the SOLIDWORKS version has always been in the way that we are modeling the optical properties, and by treating the models as solid bodies instead of individual surfaces, the management of these bodies that are in contact with each other can now be handled automatically. The software is able to recognize the optical properties of individual bodies and also the external materials, and can correctly simulate this effect. So maybe we can talk further offline, Harold, but it doesn't necessarily ignore the gaps of the model. It's more that if the gaps don't exist, so if the 2 bodies or 2 surfaces are actually in contact with each other, previously in the OPTISWORKS software, there was quite an elaborate process that had to be used in order to actually have these 2 surfaces being tangent to each other. And so because of this, I know a lot of users were adding in an air gap to make it simpler to model. But with the new version, this air gap is not necessary. So if the model has bodies that are tangent to each other, it's not necessary now to add in an air gap. But if that doesn't answer it, Harold, we can talk after the call. Sure. Okay, Harold, I'll give you a call after this webinar is completed. Vladimir, to answer your question, I am not familiar with these silicon lenses, but if a material file can be created or can be found for the silicon property, which I know that we have at least one on the portal, I don't see why we would not be able to simulate it. But if there are some specifics in regards to that, then it might be something that we would have to discuss. So if anyone has any concerns about this new platform, feel free to contact me offline and we can discuss. Overall, I think that it has several benefits that can be taken advantage of. In particular, the tangent body management and the simulation export, I think, will save a lot of time and will allow for concurrent parallel work of modeling and simulation. But if there's any concerns or any issues, definitely feel free to contact me. Vladimir, the limitations are essentially the same as OPTISWORKS, so I'm not necessarily aware of any physical dimension limitations, but in this sense, it has not changed from OPTISWORKS. It's still doing meshing in more or less the same way as OPTISWORKS, and so any limitation that was previously there, if any, would still be there. But if there is something that I'm not aware of, we can talk. You can send me an email and we can look at it. George, to answer your question, it's extremely easy to switch back and forth. Essentially, in SOLIDWORKS, in the add-ins section, instead of selecting OPTISWORKS add-in, you would select SPEOS for SOLIDWORKS add-in. The software would have to be restarted every time you want to go between the two, but that's essentially all that you would need to do, is simply to switch the add-in that's being selected. But do be careful with trying to open the same project in the two different platforms. That will cause some issues. So I would go back and forth only if you're switching between different projects. In terms of compatibility, the SPEOS for SOLIDWORKS platform is compatible with the 2015 and 2016 versions of SOLIDWORKS, but do be careful with the SOLIDWORKS version that you're using, because OPTISWORKS I believe is only compatible up to the 2016 version of SOLIDWORKS, and so I would avoid upgrading to the 2017 version of SOLIDWORKS until you're fully ready to switch to the SPEOS for SOLIDWORKS platform. Sorry, the SPEOS for SOLIDWORKS is compatible with 2015, 2016, and 2017. So I would recommend staying at SOLIDWORKS 2016 until you are fully ready to move on to the SPEOS for SOLIDWORKS platform. Yes, Vladimir, you can. Simply send me an email just as a reminder, and I will take care of that for you. So the question was whether the SPEOS for SOLIDWORKS licenses are available as of right now, and the answer is yes. So whenever you are ready to start trying the software or to switch to the software, just contact either myself or the support email, and we can take care of that for you. I'll leave the webinar open for another 10 minutes if anyone has any questions. But if not, thank you all for attending. Hopefully this was useful in providing some of the information about this new platform. And definitely if you have any questions or any concerns or would like to have a license for this new software, definitely feel free to contact us, and we'd be more than happy to provide that information. Okay, thanks everyone. I'll go ahead and shut off the webinar. Harold, I'll give you a call at 3 o'clock. Thanks for attending.